Okay, let's see if I can summarize my summaries. Page 30. Atomic structures, sequence of colors. Heated surfaces, flux, intensity of light. So it's about the intensity of light distribution. Heated surfaces emits light, and the distribution of the various colors of light of heated surfaces. Then some radiation law. Temperature, stars, total light emitted. So light emitted from heated surfaces. They specifically refer to stars. You can actually see there's a group of stars where you can, with the naked eye, that you can see that the stars are various colors. They're not the same color. So the hotter stars appear bluer and cooler stars appear redder. The light distribution differs for the various temperatures. Then the peak intensity, and that's the color of the star. And black body, the intensity of the light as a function, how it changes with the wavelength. And then if you've got a different black body at a different temperature, the light distribution will be different. So they had curves, light curves, showing this, how the intensity changes with wavelength depending on what temperature the black body is at. So it's something about heated surfaces, emission of light, the intensity at the various wavelengths are not the same. They peak at some intensity depending on the temperature of the black body. And then they fitted some mathematical formula. With mathematics, you start with certain assumptions and then you apply the mathematics, and the maths then show you what the distribution should be like. And there they found the ultraviolet catastrophe, that the maths couldn't fit the curves at short wavelengths. So there was something wrong with the assumptions. Black body curve, quantization, and oscillators, the frequency. So they had some oscillators that produced, they assumed they were oscillators that produced this black body curve. That's the maths. This intensity distribution of the various colors. How should it come about? Quantizing photons, Planck's equation. Black body frequency and black body. Let me just have a look here at page 35. I think that refers to the frequency, Planck equation frequency, black bodies. So here I'm getting a little bit lost what that F means. Most likely frequency, the frequency of the photons. So at this stage I'm not sure how photons came into the picture. Planck brought the idea of photons into the picture. So my summary is not getting there. I'm getting lost. Now, I thought there's two ways of approaching this. Is actually going back to these pages and see if you can fill in more information, get a better picture, or alternatively one can have a look on the internet. What can you find there, and see if you can make more sense of it. Max Planck thermodynamics. Thermodynamics is heat, energy, all that. Mathematical atoms. So seems they're struggling to make the maths fit to the black body curve. Of course, you can't get away from that. That is measurements of the real life. So they're trying to fit the maths to that curve, see if they can get it to follow the curve. And then comes the photoelectric effect. How light interacts with matter. Matter and light action, frequency of light, intensity of light, photoelectric effect, light quanta, photons. So I can't connect the two. I can go into my memory because I know the theory and I did study it, and if I give myself a little bit of time, I'll be able to dig it up from my memory. But the idea is, when you read the book and you look at this summary, you should be able to get the idea what is the author conveying. And I'm having difficulty to see how everything fits together. The information is there, but how does it fit together? Frequency of light, intensity of light, photoelectric effect, light quanta, and photons. So if the photoelectric effect comes the idea of light quanta. I think the oscillations of those oscillators theory, that's a continuous process, while the photoelectric effect shows you that light is quantized. You get little packets of light. So that's the other side of the story. Electrons, frequency of light, energy, so it's the photons and the electrons. The electrons are emitted, so how does that relate to the black body? Einstein, photoelectric effect, Planck's light quanta. So what can I make out of all this? This is just a chapter that spells out the problem, and he will maybe illuminate it and explain it more in the next chapter. I'm not sure. Planck's light quanta. So the idea of light, little packets of light, photons, the energy of the photons, how it changes with the frequency of the light. So that's the views of light. One is frequency, so there's oscillations, but there's also packets of light. Black body curves, Planck quantized light, Albert Einstein photoelectric effect and light emission. So I get the picture, but it's not making a lot of sense for me. The chapter is not making sense. So I'm not sure if the next one, matter waves, will clear it up. I'll have a think about it, and if I'm going to put more information into this. But that's what I got from summarizing the chapter on my little pieces of paper. This is a star cluster visible near the Southern Cross, which one can see in the southern hemisphere. There are quite a few stars that one can observe with your eye that are reddish and bluish in color. The star chart, you can download the star chart in the description.